Well, oh, welcome to the October 29th, um, 2024 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been fixing my 3D printer. I got it working again, and so a little bit of that. And then I also worked on getting ready for the Tapper membership meeting, which we had last weekend. Many of you were there. Um, and I want to congratulate Paul Elliott and David McGaw for stepping up and becoming our newest board members for this year. So congratulations. And we look forward to, oh, and then also Ed uh, Dunlap volunteered to try to learn the treasurer's accounting system for Tapper. And we really appreciate that. So thank you very much, Ed. So that's it for me. Next on the list, we have Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Last week was very busy for me. We had the W3 USR dedication, which went extremely well. And on here I can see Ed. Ed actually attended, so I got to see Ed in person. And we had the NSF program manager, Shika Rezada, come and Rosie Schechter and Ria Jairam from ARDC and Gary McKeaton came. It was really great. The night before the dedication, we were on the air for a couple of hours. We got to talk with Angel WP3R down in Puerto Rico for about 25 minutes. He talked with everyone in the shack, and a WVIA reporter from NPR stopped by too and did a really nice segment on us. And so you can see that in the chat. There's a link to it where you can read the article, see the photos, and you can listen to this segment. So now I'm back to doing regular schoolwork, well, sort of regular for schoolwork for the week. I've got some special assignments that are keeping me extra busy, but I'm trying to make it through that. Back to net.
Very good. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Hello, everybody. I've been um, maybe a little busier than usual and even a little more productive, believe it or not. I've been trying to get another batch of a slightly updated design of the magnetometers off to JLC PCB and get a few back for testing you know, um, before I make a final decision on how many. And then I've also been working with, I met with Franco the other day, discussing a dual uh, ADC variant of the, well, Clementine or what have I called it? I think I'm calling it Xerxes at the moment, just because uh, I needed a different name. And so I've been working on getting a presentable schematic of that all together. I'm just not very good at making the little footprint designs. That's the hard thing that's hard for me. But other than that, been just plugging away at stuff, little software as well. So that's it for me.
Okay. Next on the list is Paul Elliott. Go ahead, Paul.
Yeah, evening, afternoon, I guess evening, everybody. Board meeting, annual board meeting for Tapper. That was, quite interesting. Looking forward to that. And just working, did my, I guess it'd be bi-weekly shift from Friday Harbor down to Occidental, where I am right now. And getting stuff prepared to ship up over to Germany, which will then end up in Antarctica for our, basically it's a HamSCI type setup. There are going to be a couple RX 888s and a whisper sonde down there at the German German station down there, and that should be getting mailed out to Germany in a day or two, and then hopefully not interminable wait to get it through customs and then onto a ship going to Antarctica. So hope everything gets there in time. Other than that, just goofing around with radios. Okay, back to net.
Okay. I always enjoy watching that German research boat go up and down the Atlantic, up to the north, the Arctic, and then down to the southern hemisphere, over a year process. Anyway, next on the list, we have Bill Engelkey. Go ahead, Bill.
Thanks, Dave. Just a couple of items for this evening. Let me share my screen here. I'll show you what the team has been up to. Right there. All right, you've seen this before. What's new is the legend.
Oh,
We
yes.
added a new status of retired. Those are stations that haven't submitted data for like more than a month. But we can't delete them because they still have plenty of valid data that they did upload. So I told the students, okay, I want this legend here, this word legend, to actually be a link that takes you to a definition of these, because it's kind of really unclear what we mean by these until we put some documentation behind it. So that's what we're going to do. So there's one other thing that we have. Do you see that garden there now?
Mm-hmm.
Yeah.
That we have more fall color than I have ever seen in Alabama in 30 years of living here. This is leading out into our garden. Rob Robinette is always telling me how nice and quiet my location is, and I need to understand that I live out in the middle of nowhere. These are some multicolor azaleas. We have all encore azaleas, and they produce flowers twice a year, once in the spring and once in the fall. And there is a picture of the QTH from the lake. And here in the middle, I'll zoom in a little bit, you'll see there's a tower in the middle of that.
Oh, there it is.
That's beautiful.
There you
Yes.
can see the tower a little bit.
Wow. Where's the
Right
tower?
Right. Yeah.
Oh yeah.
Yeah,
That's
you see,
great,
we have a
Bill.
lot of tall trees. The tower does not go higher than the trees, and so I don't necessarily think I'm much of a lightning target, you know, and lots of stuff higher than the antenna is around there. This is looking from our back porch out over the lake. And as you see, there's not much around me.
No.
This, I don't know if you've ever driven through the Delaware Water Gap, but this what this kind of reminds me. This right here is what we call a North River, and it
Yeah.
goes way back up into the hinterlands. And this is a man-made lake. This is Lake Tuscaloosa. It used to just be a river through here, but they dammed it up in the late 60s, and that is Northport's drinking water. So let's see. Yeah, that's the picture show. Anyway, so you can see how I can do some good observation with having a radio quiet location. So back to net. And by the way, today is my birthday. I'm 73.
Oh,
Happy
congratulations.
birthday, Bill.
Yeah, thank you. Back to net.
73.
Yes.
88, all that.
Next on the list, we have Bob in 5BRG. Go ahead, Bob.
Hello, everyone. I spent a fair amount of time this week working on my Meteor capturing software, which is really distributed by others, but I'm trying to upgrade it to allow it to run on 2404, which is a real challenge because you're chasing all kinds of Python modules and things that don't necessarily get updated or walk along with everything else. but making some pretty good headway, it feels like. But that's what I've been up to anyway. So back to you, Dave.
Very good. And next on the list, we have Brett Anderson. Do you have any comments, Brett?
Oh, just a bit of a straggler coming from Rob's group. I do mainly operating system and deployment support with Rob, and he invited me to kind of hang along and listen in. So I'm currently sitting at 8,200 feet at a microwave site waiting for batteries to charge and had nothing better to do.
Well, we're glad you're here, and please come back if you find it interesting.
Very well.
Okay. Next on the list is Bruce, WB4MJGE. Go ahead.
First time viewer. Been following HamSCI on the web for a good time. I think my video is probably not on.
There you go.
Yeah, just thought I would jump in and see what all was going on. Been following some of the projects, and I'm retired now, so have a little bit of time to do some things. So other than
Well,
that, nothing at all.
very good. We're always happy to have you, and we talk a lot about how to develop the radios more and
Right.
specific details on them.
Yeah, I've been following the Space Weather Station and
Yes.
Tangerine and the magnetometers
Yep.
and some of that stuff.
Very good. Well, next on the list is Clint, KA7OEI. Go ahead, Clint.
I just not a lot to add, so I'll just throw it back right at you.
Okay. And let's see. We got Dave. So the next Dave is W6OQ. Go ahead.
Good evening, everyone. As usual, I'm just here trying to, follow along with what's happening and seeing, where I might be able to fit in. Thanks.
Okay. And next on the list is Dave New, N8. Well, it just jumped on me. SPE. Go ahead, Dave.
Yeah, hi. Yeah, I'm kind of like the other Dave, W6OQ. I'm here just to see where I might be able to fit in. So I'm just playing the fly on the wall right now.
Okay. And let's see. Next we have David McGaw, the new TAPR board member.
Thank you, everyone.
Go ahead.
Well, just another week working on various projects. I was moving some cables around today because I've got to move things up on the roof at the lab. We're working on RFI mitigation, I hope. They're working our building with LEDs and claiming that they can't find residential rated replacement tubes for our fluorescent fixtures, even though we know that they're available. And I told them where to get them. I can tell them where to go, but we're trying. We're trying some various options. I get to do a little more RFI snooping tomorrow. And I guess that's about it. Continuing to work on evaluating antenna ideas. But that's kind of going a little on the slow side. And watching the sun. We got another little burble
Yes.
today, but nothing major. But there's one big sunspot that's still threatening. So fingers crossed we get another good piece of excitement coming through. And also, we're continuing to work on the cinema movie project, which probably will have a pretty good HamSCI side to it, at least in terms of hardware. But we're seeing what we can do with that. That's a proposal in phase A with NASA. But hopefully comes through and gives us some more citizen science initiative. Back to Net.
Okay. Next on the list is Dylan. Go ahead, Dylan. This, it doesn't look like he has a mic on there. Do you have a mic? Yes, you do.
I have a mic now. Oh, my camera is on. Okay. Yeah. Currently just working on my car. Decided the VWs are wonderful when the dual mass flywheel decides to go out. So now I'm in the middle of trying to remove the transmission. Yay! So yeah, that's what I'm in the middle of right now. Fun, fun, fun. But other than that, nothing else. So I'll send it back to you, Dave.
Okay, very good. And next on the list, we have Ed in 3ED. Go ahead, Ed.
Hi, yeah, this is mostly for Nathaniel, but up at the meeting on Friday, I connected Shakea with Mary Lou West for about 15 minutes. And I also suggested to Shakea that she try to get a tiny bit of operating in, because I think she just got a license just as Arecibo closed down. She was down there. And so it would be really useful for an NSF person to at least get a tiny bit of operating, especially at your station, which is really great now. Back to Ned.
Yes.
I'm happy
Very
to
good.
report that Shika did get to operate, and she's actually good friends with Angel WP3R, and they got to talk on 40-meter phone for quite some time.
Very
Oh,
good.
that's amazing. That's great.
Yes.
So, yes, I
Now she'll have to upgrade from technician.
I
yes.
know. She left very happy.
Well, that's good. So, next on the list is Jamal. And like always, he's in Egypt, so it's early in the morning for him.
Yeah. Thank you, Dr. Dave. Good morning, everyone. Just have been passing by a very stressful week, packing up the fruits of working on Far Lab. Just I've been trying to insert a fictitious scenario. If W3 USR has been dedicated in 2001, so how can I be in Cairo to receive the signal? Because I'm working on the model of the IRI 2001 and 2020. That was really challenging, but it began to pay off to get things to be assembled together. Then working on the bearing and how those calculations might be very strict on MATLAB. So the most important thing, and thank you, Dr. Nathaniel, for teaching me how to get out of the perfectionist box, because to the multiple, yeah. Being perfectionist, yeah, I should get out of this box, because
yes,
it's very complicated. And then Dr. Nathaniel told me, hey, Gamal, the model itself isn't that one that you think. It's modeling. So I'm getting out of this box right now.
I have to say,
please wish me the best.
Go ahead, Nathaniel.
Yeah, definitely. I saw the email you sent tonight. The figure looked really good, and so did the numbers. And when we get to the open session, I'd be very interested in having you show everyone that. And would like to hear more about the numbers, because I think what you're doing has the potential to be very useful. And I'd like people to see that and be able to comment on it.
Very good.
Yeah.
So.
Yeah. Last but not least, Dr.
Sure.
Bill, happy birthday. And I'm very glad that last Thursday was also my birthday. So thanks for having the same week, 2 birthdays of Hams.
Yes.
Thank you so much.
Okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Hi, everybody. Nothing new amateur radio wise. A general announcement: the Radio Club of America will be having its annual technical symposium and meeting in New York City in November. I put the dates and information, link to further information in the chat. It's so. Hope you all can attend or think about attending or can make it available to attending. A couple of the interesting things, one of the interesting things is they're going to be touring on taking a side tour to the horn at what used to be Bell Labs, where the horn that discovered the cosmic microwave background radiation was discovered. And also, I believe on the Saturday night banquet, one of the Nobel laureates that was one of the three guys that discovered the cosmic microwave background radiation is going to be the guest speaker at the Saturday night banquet. So more information, the link is in the chat. And with that, 7-3, back to net.
Okay, thank you. Next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have too much VLF related news this week, but I just want to say congratulations to Nathaniel for all your hard work and effort, both you and Rachel, for all the hard work and effort, and everyone else involved in the W3 USR station dedication. It was absolutely wonderful. It was wonderful to see everybody, and I had a really good time chatting with everybody and dedicating such an awesome station. I remember that I was at the time when this was in its infancy. I was the from what I was aware, there were only two people licensed at the university, which was me and Nathaniel, and I remember signing the vanity license application, and I can't remember if it was the vanity license application or the club license, or the club license application, but a co-signer was required that was licensed. So it was really cool to see it grow from that point. So thank you again, Nathaniel, for a wonderful time. That's all I have. Back to the net.
Okay, next on the list, we have Michael Howen, AC0G. Go ahead.
Good evening, everybody. I took, I got some amplifier shelving kits from Paul, and so I currently have a standard link from each of 4 antennas to 4 computers. So 4 separate antennas, and they all are fed through one of those shelving filter amplifier jobs, and the timing adapter for the 888. So that gives us at least a little bit better uniformity across the 4 different antennas that I have up, one of which is the DX engineering antenna that was a part of Nathaniel's original grant proposal. And another is a LZ1AQ loop antenna. The third one is an inverted L, and the fourth is a 3-legged folded terminated dipole. So those are the four antennas running here. I've also got the field probe that Rob sent me, and I got to reimburse you for that, Rob. And I've been wandering around my yard trying to figure out what the hell it's telling me. So back to net.
Very good. Next, we already talked to Paul. So next we have
Oh yes,
Phil.
Rob, we got our field probe too. So if you need a reimbursement, talk to Majid or Salisa. We'll get it reimbursed.
Okay.
Well,
So we talked to Paul. So next on the list is Phil, K9Q. Go ahead, Phil.
Hey guys, recovering from the flu picked up on this last week's travel, so really nothing to report here.
Okay. And next on the list is Scott Newell, and he usually has no microphone, and yes, it's still the same. And then we have Tom McDermott in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everybody in the group. Did a couple of concerts this week, and that kind of took out most of the time for everything else. So recording and editing and all of that kind of stuff. So back to the group.
Okay. So I think we've been through the list. And oh no, we have Rob Robinette. Sorry. Go ahead, Rob.
Okay. Well, I'm happy to be last because I tend to. You should hold up your hand when I have talked too long. Let's see. My major activities. Let's see. Have been. I went out to KPH and upgraded. We found and corrected a ground loop out at KPH and removed a band of RFI. That was at 14 megahertz. So there's, I think that for this group, the lesson is that there's always a way to improve your receive system, and you should use I think that we almost should have a study course, I think, on how to go about and identify and improve the quality of your receive site. I mean, there are sites where we have improved the receive sensitivity by 20 or 30 dB. And that wasn't the case at KPH, but that has been the case at other sites. So I think part of my goal in the antenna project and working with Michael and others is to provide the HamSCI community with the tools. I mean, the field probe is one of them, but more importantly is the understanding of how to use the tools and how to identify and eliminate the sources of impairments, that are coming into your receive systems. So so we did that at KPH. Not using we didn't need the field probe out there. It was a problem that was internal to the inside the building problem. But different sites have different sets of problems. So that's let's see. I can't remember what else that's relevant. I've kind of been focused on transmitting, which is for my project I talked about earlier, the Beehive monitoring system project using transmissions, Whisper, on 22 meters, the ISM band, and it's startling how efficient Whisper can be if you set up your transmit site appropriately. I'm transmitting using an RF0, and I have people receiving me on the East Coast 20 milliwatts into a full half-wave dipole. But it's tacked to the siding of my townhouse here, so it's not a particularly effective transmit antenna. So the other thing is I'd recommend to the group, if you're interested in the results and analysis, how we tend to focus on the hardware here, but the goal here is really to obtain, I mean, my goal, and I think all of our goals, is to obtain new insights into the interaction, space weather interaction with our atmosphere, and using Whisper to do so. And Gwen G3CIL shared this morning a preview of the presentation he's going to give to the HamSCI science group on Thursday afternoon, this Thursday afternoon. And I'd encourage any of you who have the time, who perhaps haven't regularly attended those online sessions, to consider trying to do so this Thursday, because Gwen has obtained some really exceptional insights, I think, and into the data that she's extracting from the HamSCI's database. This is going beyond the looking at the spectrogram charts to extracting the data, applying machine learning techniques to it, to better understand, to identify them, as it seems, multiple propagation paths that are coming from WWV. And these are conclusions that I think are very difficult to come from visually. So I think that Gwen's work here is something that is, I hope, would encourage others. At this point, I think we have a wealth of data. We have a huge trove of beautiful data that's going in every day. We do not have enough people looking at it. And I would, I would hope that Gwen's presentation might encourage others to turn their attention from, RX888s and all this other stuff to actually looking at what these things are recording and what things we might learn from it. So that's my major message for this evening.
And I completely agree with everything Rob says. And Gwyn, I think he has consistently impressed me with always coming up with a very insightful analysis.
What's wonderful to me from his preview that he showed me this morning is that he's identified things that he can't explain. This is exactly what we want to see.
Yes.
We want to see things that we don't know why they occur. I mean, this is the essence of scientific investigation, in my understanding of it, is to make observations and say, wait a second, I don't understand this. I don't know. I was inspired by watching the PBS Nova about Vera Rubin and the understanding about presence of dark matter, that she, measured the Doppler shift, in essence, of the stars on the circumference of Andromeda, and said they're moving too fast. We can't explain that. And that is exactly what that kind of scientific observation, experimental observation, is what I find most exciting. And I hope that but if we're not looking, if we're spending all our time gathering data and not looking at it, and I'm not the right person to look at it. I mean, I'm so impressed every time I see what Gwen's work is. I'm so gratified to see that, and there are others. I know that Gwen is not alone, but I would like to encourage those those researchers, investigators, that we really value your work and want to encourage you to continue and deepen it. So anyway, for now, I'll send that back to Net, and I can.
Okay. Well, I agree with you, Rob. One of the things I've been amazed at is the motivational discussions for this project were eclipses, but I'm of the opinion that going through the solar cycle, particularly at the peaks, we may find it more and as interesting or more interesting phenomenon than just the eclipses affecting ionospheric propagation.
Yeah, there seem to be things occurring daily, almost daily, that are unexplained. This is William Shatner's has a program called that. So I think we could co-opt that into a true scientific investigation. that we're doing is that we're looking for things that are unexplained and look for the explanations. Try to come up with the explanations. This is a wonderful puzzle for us all to solve, and it's wonderful that that Nathaniel, you've assembled this group to make these investigations and be able to to obtain funding for it. So I'm looking forward to it. Well, I did work with Paul to we created one of the goals that I have is to extend our observations from now primarily North America and even a little bit in Europe, to extend them down into the southern hemisphere and to Antarctica. So I've got we have a shipment going off to Michael Harche, Professor Harche, to take down to the Neumayer station in January. That should provide us with just a rock solid, hopefully a rock solid reference transmit and receive site down there. But I haven't been able to respond to. I have another opportunity for Australia, which I haven't. The whole GV0 thing. The German station has preoccupied me for the last few days, so I haven't been able to work on that. I'm going to send a note off to Jerry, who is the person who's contact for that. But I think gathering data from other parts of the world is really one of the elements, one of the frontiers for us. I think we now have a pretty well established monitoring architecture. I think so the issue is, and I think that's we're moving to the deployment phase, so we need to get deployments out there, and we need to figure out how to support them. We need an antenna. Michael, we're working on that part. The rest of the elements, I think, are. I mean, I don't know much about the magnetometer system, but my sense is that it's pretty well established how to do a magnetometer and order one and so on. And I think we're at the stage where we know what all the parts you can order for the receive system, the shortwave receive system. So I think we're pretty close to having the site componentry and how to deploy them pretty well established. I'm trying to do my part to find the places to actually get them deployed. And of course, my focus is outside of North America. I mean, I'm kind of interested in
Rob, along with the desire to put things in the Southern Hemisphere, I copied you on an email or sent an email to you last week where we have a postdoc named Kukai who's looking at equatorial plasma bubbles. And she has a big interest in looking at trans-equatorial propagation. So I think we'd be very interested in having good observations going from North America to South America and vice versa. So if we can also increase those
good. I
routes.
have one good receive site in Brasilia.
Okay.
Okay, already. He's very, very good, reliable Whisper Demon site down there. I'm not sure if he's GPS disciplined, but anyway, we can. But yeah, I'd be happy to work on that. I want to help. Now that I pretty well understand the issues, deployment issues, I think I have a pretty good handle of what components are needed. I want to help people get their systems deployed. So find more
That
and
sounds
find
really
more
good.
sites, find more systems, find more sites.
Yeah. I'd really like. I think we'll have to have a meeting with you and with Kukai and Gwyn to look at this the project that she's working on, because I think it will be of interest to you from the perspective of wanting to get more stations out there, and probably for the interest of Gwyn, because I think you'll have good insights on how to do some of that analysis. And Kukai, Ed got to meet Kukai this weekend, and she's very good.
Yeah,
Excellent.
I can second that. She's I looked over her poster multiple times, and she has done a significant amount of work between Japan and Australia, and there's because she was her graduate degree is from Japan, and they were doing transequatorial there, but on, I guess it was 20 meters, and so she's now over here, and she is very knowledgeable. I'll just leave it there.
Great. That's wonderful to hear. Just wonderful. Anyway, that's I think we have
Well,
Did we make it through the
well,
through the roll call yet?
if Rob is
I think we-
done with his report, we'll
I kind of
open it.
wander on. I wandered on, so I'm sorry if
We'll make it open for general discussion.
I'd really like Jamal to show us what he's been working on, because I think it's good, and I think we can also probably give him some good feedback.
Oh, what? Yeah. He's getting set up. I think you surprised him.
It's very possible.
You've got to unmute,
Quick, the
though.
bosses want to. Quick, the bosses want to see your work.
Yep.
Can you just jump over to the ray tracing part?
And also his microphone's muted.
Yes.
Okay. Is that nice?
Yes,
Okay.
we can see it.
We hear you now.
I just wanted to thank Dr. David Magao for his feedback 3 weeks earlier about
Yeah,
the
Gamal,
thank you, Dr.
two
David.
things first. One, I am not a doctor, so please drop that. Thank you, but thank you. And it's Dartmouth College, not University of Dartmouth.
Yeah.
Different place.
Yeah.
Mm-hmm.
An eagle eye.
I'm a master, not a doctor.
But we'll follow along.
But thank you for the acknowledgement.
Yeah, I would be very glad if you can speak a little bit about W3 USR during the presentation, but it would be much later during the representation there in Coimbra.
Wait, Jamal, can you jump ahead to the part with the ray tracing? I think that's because you sent me an email tonight, and I'm curious. That's the part I'd really like to focus on right now.
Yeah. Okay. Yes. Here's it. Yes, from Scranton to Cairo. Yeah. Here's.
Okay, great. So you're running Farlap now, which is really good, and you are using the IRI. So from 2001, which is fine, I think. It's at least a start, and you have your okay. We'll have to look at the input parameters. I see you're using 3.7 megahertz, and you have your smooth sunspot number set to 100 at the moment. What I'm really curious at the moment is, how did you come up with that total absorption number?
Yeah, actually, I just found in the workspace in MATLAB a parameter called two parameters. They are very important. The read trace and read trace data. So
What was?
I just
Can you say that again?
yes, it's called sorry, repath and repath
Path, right?
data. Yes, yeah.
Okay.
These are two output parameters in the workspace after I ran the FAR lab for this setup. from the transmitter to the receiver, and what makes things much more simpler than the first one, Parlab, having multiple ray traces, multiple rays from transmitter to receiver, is that this setup of interwhisper are designed for zero angle of elevation. So we in this study in the geolocalization, we are interested in the first ray trace, which is zero angle of elevation.
Mm-hmm.
So it makes the calculation process much more simpler. Otherwise, we could have about 60 ray traces per run. So again, as a result, we have two very important parameters, is ray path and ray path data. And
Mm-hmm.
actually, I figured out that it's not a simple parameter. They are two structures. Structure
Jamal, if you
containing.
could back off the microphone, you're overloading it.
Okay. Is that nice?
Yes.
That's better.
Okay. Okay. I was just trying to keep the signal. Okay. So these two parameters are not just mere x and y and z. No, they are two structures. Each one is a structure containing all data, most of the data required to obtain from the signal. So if we are going to take the ray path, for example, the ray path, it takes the most important points the ray may pass through, which is the first interaction with the Earth here at 3,000 kilometers, for example. That's the first stop. Actually, what we are experiencing at hops. So so if we're going to explore what is this ray path, we should have,
Mm-hmm.
for example, a variable that's called latitude, and another one is longitude, and this is an array. Each one contains the latitude and longitude of the intersection of the ray with the ground. For example, here we would see this latitude and longitude, and this one latitude and longitude, this one and this one and this one, till we reach
Mm-hmm.
our receiver. So at each hop, it tells us what is the accumulative absorption of the ionosphere. So we have another parameter inside this structure called the total absorption and the Doppler shift and etc. So I took that total absorption and try to get most use of it. Another
Mm-hmm.
one that is really important, and
So
I think I don't know.
did it say what goes into that total absorption number?
Yes, actually, it just gave a number, which is, yeah, at the eighth hop, at the last hop, it tells that the total absorption is 137.18 only. So I was curious, which unit is it? So I went through the another MATLAB help file, and it tells that
Right.
the unit is decibels. And it's
Right.
not absorption in the last hop. No, it's the accumulative total absorption.
But I
So that.
guess so when I say what goes into that, does it say like so I think you have the total cumulative absorption. I think it would include what you call deviative absorption, which I think is the absorption that occurs in the ionosphere as the ray is bending,
Yeah.
I think. And then I
Yes.
think there's also an absorption that is probably from the ground reflection as well.
Okay.
And I think there can also be something called non-deviative absorption, which is absorption through the ionosphere as it's not bending. Maybe from like a so I'm curious when it's calculating that number, what it's taking into account.
Yeah.
Does it
Actually, yeah.
did it give any of that breakdown?
Yes, till what I've been tracing is that it tells that they ignore the effect of the geomagnetic field.
Mm-hmm.
So at that moment, the total absorption is much greater than the ordinary component and much less
Mm-hmm.
than the extraordinary one in the
Mm-hmm.
absence of geomagnetic field. So so in another MATLAB file, they considered the geomagnetic field to
Mm-hmm.
obtain the 3D
trace of the ray trace itself. So at this one, they neglected the geomagnetic field effect. I'm trying to at every feedback I'm getting back to know what's going on here. So it's not that straightforward. So but I'm very keen to know the three parameters you have just mentioned, which is the deviative absorption, the ground reflection one, and the other non-bending absorption.
So I think the other thing I'd like to know, which I think the personal space weather station can help with if we do it right, is I want to know if this number has any basis in reality. Like I would really like to know. We know what WWV is, right? We know where that is. We know something about that antenna pattern. We know something about how much that's putting out. And we now have these Whisper Demon receivers across the US that we also know something about their antenna patterns. And I'd really like to see, what I would like to see is if you could run this calculation in a way, model the transmissions from WWV to a number of Whisper Demon receivers and see if you can show the relative change in received signal strength if what you're showing here with the model matches what we're actually receiving. That's what I'd really like to see.
Okay.
And I think the first step to that is, I think going from Scranton to Cairo is nice, but I think maybe going from try going from from Colorado, Fort Collins, Colorado to Scranton, or Fort Collins, Colorado to KPH, and see how that lines up.
Okay. Do you have certain grade, doctor, to be studied? A certain grade that we are interested in, so that I can use it in the model?
Yes, we do. Exactly. We know exactly. Yeah. What's that,
He
Dave?
can send that to you, but I have a one quick question about the assumption. Is this assuming a smooth surface sphere for the Earth?
I think it is.
And no mountains, no topography.
I think so.
Yeah, and then so
Yeah, you also have to simulate Earth versus water.
yeah, the bounce directions would be affected by the assumptions of what it's bouncing off of. Now,
I think it's very idealized, but perhaps we start with even though it is idealized, perhaps we just start with getting it as close to reality as we can without having to rejigger it too much. And, just say, okay, we start with a transmitter in Fort Collins, Colorado, and we do a few known receivers like the one at KPH. We do the one at my house. We can pick a couple more, and let's just see it. I mean, let's just see if we can get the absorption levels to change correctly from day to night.
Right. And has Jamal received your station at his QTH?
I don't think. No, I doubt it.
Oh, okay.
No, I think he's just making this up, but that's what I'm saying. Instead of just making this up, we should do real, actual
yes, I think I would also avoid multi-skip paths. I think that that just introduces another variable into the analysis that.
But that's why I wanted Jamal to show this, because he's working on it, and I think
that's great.
The fact that he has actually opened up MATLAB and he's actually running these ray traces. I think
wonderful. This is
that's
wonderful,
the first
Jamal.
step.
Yeah.
It's a challenging job for anybody to sit down and learn how to do that.
Yeah, no,
I bet
think this
most
is
of us couldn't do it unless you invested some time into it.
I mean, that's my problem. I'm totally out of time. But I do think I do think that there's some good value in this. And but I think that's I would really like to see you run some different cases, and I'd like us to try to understand what that absorption parameter means better. And
Yeah, well, one thing that I'm noticing in this particular simulation is it actually shows it's skipping over Cairo.
Yes.
In other words, so I really question the absorption figure. But is there a way to run FARLAP so that you have as the parameters the transmit and receive station, and then it looks for possible paths in between?
yes, we can do that. There are ways to do that. But so Jamal, how about we do this? The main transmitter that we are using right now is WWV, and that's located in Fort Collins, Colorado.
Okay.
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 And we have receivers in a number of locations throughout the United States. But for now, how about if you do the two that I know off the top of my head? You can do the one at my house in Springbrook, essentially Scranton, Pennsylvania. It's only a 5-mile difference between Springbrook and Scranton, so I think it's close enough. So so go from WWV to Scranton, Pennsylvania. And why don't you also do WWV to what do you say, Rob? Like not to KPH.
KPH or yeah, use KPH. It's pretty.
Do you need the lat long for K?
I don't have it here, but you can see it on just
It's obvious on the map because
yeah,
it's peninsula, almost island.
Yeah, just search Google Maps, maps.google.com, and put KPH receive site, and you'll see a picture of it. I mean, Google Earth picture of it. So,
what's the location, Rob? Is it on a cape?
It's on.
It's out on the peninsula. Yeah, it's a historic radio site that's a national. It's now a historic.
But I'm saying, what's its physical location?
Physical location is about 30 air miles northwest of San Francisco.
But I thought it was named.
It is a national park.
Here, I'm putting in the chat.
Look at Point Reyes National Seashore.
That's
if you
what
want,
I was looking for.
I can give you the latitude and longitude right now. I've got it up on Google Earth here.
Yeah,
and I just put a link in the chat too, if that's
okay.
If that looks correct. So Jamal, if you can do Fort Collins, Colorado to Scranton, and Fort Collins, Colorado to KPH, and maybe start with 5 megahertz, 10 megahertz, and 15 megahertz.
Okay.
And do it for April 8th.
Okay.
And I guess sure for now 2001, because I think that's what
model.
I know you're using the IRI.
Yeah.
What's that?
Yeah, I don't think there isn't whisper data. Well, 2001 is
well, the problem is he's using an empirical model that only goes up to like 2017 or 2018, something like that. So the model more sort of repeats every 11 years.
Yeah.
But so this will just get us in the ballpark for now.
Okay.
Okay. And why don't you do that do those in a new, so create a new PowerPoint for this.
Okay.
Okay, and do this in a new PowerPoint. And let's see the ray traces for those next week. and see what you.
Okay. The presentation is going to take place in Coimbra. Oh, okay. You
Mhm.
mean, doctor, it's to be separate from that to be presented at the workshop
Yeah,
at
yeah,
the
yeah.
European
To be
space?
separate from the space weather workshop. So we're gonna. This is what we're giving you is we're giving you an assignment for a completely different presentation. Okay. But I think I think what we're asking you to do is going to be much more connected with the data that we have.
Okay.
Okay. What I'm worried about with what you're doing right now is I'm worried that these models are just so far detached from reality. I'm not sure that it's really going to be useful. But I think that if we start to rein them in a little bit and try and compare them with some actual data, we might be able to have them be useful.
Yeah. Sure. Okay. Okay. I
Does it
just
sound Well, one thing is the transmission pattern of the transmit antenna included in this? Because what we have observed is that most real antennas that are anywhere near the ground in terms of wavelengths are almost completely absorbed. I mean, the ground wave almost doesn't exist as
So
a phenomenon.
with what he's going to be doing at first, it's he's just doing two-dimensional ray traces that don't assume any pattern, and I
Yeah.
don't think there's no assumed power transmission level. I think it's just purely kind of geometric optics sort of thing.
Okay.
But there's a lot of, I think as we go into it more in depth, we can gradually add some more of these additional constraints. So what I'm suggesting is let's just get some 3 ray traces up for 3 frequencies that we know happened, for 3 geometries that we know happened. And then once we get that up, then we can start asking those other questions. Okay, how do we include antenna pattern? How do we include, so this is just a first step.
It's a great first step. It's wonderful, Gamal, to have you looking at this. I hope
I agree.
I hope,
Yeah.
Gamal, you feel encouraged by today's discussion, not discouraged.
Right.
We're
Yeah.
very, very glad to see you looking into this. So
Yes.
I agree. I have to commend Gamal because, he came to me a few months ago and he said, Gamal has really been very enthusiastic about getting involved. And it's been very tough with my schedule and the time zone difference. But
yeah,
he did send me his presentation. And one of the things I thought was missing was the ray tracing. And and so he did go and, figure out how to run this. So I think this is very encouraging. So yeah, no, this is really good work, Gamal.
I'm speechless with you. Definitely.
And I think this is a good group to show this to because I think, the people here will appreciate what you're trying to do and give you good advice.
Yes. We have a mix of researchers and engineers and ham radio operators who don't have a strong background in either of those things. So
Well, yeah.
And that's what's, as was mentioned before, we want to look for things that we don't understand. One of the things we really don't understand is the actual path loss given propagation, because the ionosphere is not what the model shows. It is very different, but model is what we've got. But that's a good place to start.
Yeah. And I can tell you, I know that we're saying using the 2001 year for now and certain other things, but we do have access to like to the SAMI 3 model runs for the actual eclipse day, so we can eventually get those put in. But as I said, this is a really good first start.
That was really challenging for me because I'm electrical engineering. So I just felt how it's great for the astrophysicists. Yeah, how astrophysics is really really nice and it's really really great branch of science. I'm just yeah, I just figured out that I need to study the ionosphere. It's a branch of science that's really important. So yeah, thanks for the opportunity.
Uh, I don't think you'll be able to attend the Thursday presentation, but I know that they're all recorded, and you might, you in particular, might benefit from Gwen's presentation, and I'm sure he'd welcome any questions if you want some mentoring. I know he would feel encouraged to have someone reach out to him if you have questions about his work.
Yeah. Yeah, Nathaniel, I just did a back of the envelope calculation.
Mm-hmm.
And if you assume a 100-watt transmitter with 0 dB gain antenna and no ground reflection gain, and then you add 137 dB of path loss, you get about an S7 signal at the receive side, assuming no gain on the receive antenna.
Okay.
And so I don't know if that's reasonable or not. I don't know the East Coast to the Middle East kind of signal levels, but is that a good way to kind of double check the path loss, is to look at what signal levels you actually measure, the transmit power and the receive signals, and try to actually measure the path loss and then compare it against the absorption number?
I would think it's a reasonable thing to do.
Okay.
Yeah, the short answer is yes.
Okay.
No, that's exactly what we're trying to do.
I think that's exactly. I think that's what we're trying to do here.
Okay.
No, because the complication here is bouncing it off the ionosphere. When you're doing line of sight, this is exactly what you do, and it will usually be pretty close.
Right. But I would think that, if you're computing the total absorption of the path, that would be between the transmitter and receiver, even if it's going, does it count for all of the effects that Nathaniel mentioned? If it does, then I would think it lets you estimate the receive signal and that you could then
Yes.
double check those numbers.
Well, it's a convolution between the antenna gain at whatever angle it is that it's taking off at, and then the path loss, and then the receiver gain, likewise at the angle that it's coming in at.
That's why I was also asking the question, what is going into that total absorption number? Because I don't know everything that is or is not being accounted for in that.
Yeah, I wonder if FARLAP, unless you tell it otherwise, assumes an isotropic antenna.
Yeah. And that's why I'm hoping Gamal can really kind of take apart here, because FARLAP is well documented. It's a black box, but it's well documented and it's written by people who know what they're doing. So, but I think it is, up to us to read the documentation, and so yeah, I'm hoping Gamal can kind of take that apart and put it together into a presentation that we can all say, oh yeah, we actually do understand what's going on here.
Yeah. Actually, there is only one MATLAB file, and they mentioned that the function of generating this ionospheric channel, it's originally written in Fortran. The extension of the file is .4. So I don't have an access. I don't even have an access to open this function. So where can I find this function? I searched it through the internet and I couldn't find it. I thought about sending it to Survera, but I just told myself, no, keep your horse, hold on and look at the documentation.
Well, what a lot of what they do with FARLAP is they'll give you a lot of the documentation, but they won't give you the actual source code for a lot of the core functions, because they have that under like proprietary. It's not open source, but they will say, okay, this number was calculated using the formulas that were developed by this particular paper, and then they'll give you the citation. So,
Okay.
and also, do you have a copy of the book Ionospheric Radio by Ken Davies, 1990?
No.
You should get yourself a copy of that book. See if I can find Spheric Radio Davies 1990. So I'll put this book in the chat.
Either gonna be $10 or a couple $100.
Yeah.
$1,000.
I think you can get a PDF copy for like $80 if you search or something. But a lot of the definitions that are in the FARLAP documentation are defined in that book.
Okay. Okay.
So that's funny. On my computer, it says hardcover $113.37. On his computer, it says hardcover $140.90. So
And there's delivery fee.
On the cover.
This is delivered to
No,
Egypt.
Google gives different people different
Yeah.
prices.
Yeah.
So, but that is, if you go here,
It says see all formats and editions. There are
yeah.
multiple.
So anyway, you should find yourself a copy of that book. But what I'd really like to see, I think you'd make a really good presentation if not only do you calculate these numbers, but if you're also able to give a slide that says total absorption. This is what that number includes. These are the papers that it comes from, and give us those definitions too. So when you put those numbers up on the screen, we can all be like, okay, we understand where that number is coming from.
Okay. Okay. That's awesome. Okay.
Well, if it's okay, it's 10 after 10 o'clock here, so I think I'm gonna say 73 for the night. But I think this is really good. I think Jamal, thank you very much for doing this. I think the whole group is very excited to see it, and good luck with your presentation. And thank you very much, everyone else, for all that you are
Would you
doing.
like to give about 2 minute speech during the presentation? I just thought about this, but I don't know how it would be delivered.
No,
I
no,
might
no.
ask them there.
I'm good. When is the talk?
It's in November 4th at
November 4th.
yeah, at 2 p.m. Portugal timing.
Okay, I will try. I would like to review your presentation before you give it. So if you could send me your slide deck again.
I'm sharing the Google Slides with you. It's online.
It's already shared.
I'll send
Okay.
it again.
Yeah, I have to I have a lot of stuff I have to review this week. It's just crazy.
Yeah,
I will do my
papers
best.
do.
Yes. I'll do my best. I will not be able to make it to the November 4th thing. I just have too much going on, but I'm sure you'll do a fine job. But I think I would like to see you continue doing this work and sharing these ray traces with the group here.
Yeah. Thank you, Dr. Khaled.
Thank you, Jamal.
Thank you.
Mhm. Thank you very much, everyone. 7-3.
73.
Who's left?